Welcome to Get Your FRQ On. This question is from 2013. It's question 3, and it is not calculator active. In the question stem, we have a table of values for the amount of coffee being poured into a coffee cup, represented by a function c of t. The amount of coffee is measured in ounces, and we are given that c of t is differentiable. In part A of the question, we are asked to find an approximate value for c prime of 3.5 using the data in the table, show our computation that leads to our answer, and provide the units. So in the table, we are given values for c of 3 and c of 4. We also know that c is differentiable, so the work that we're going to do here, this is like a mean value problem or an average rate of change problem. In order to do this, we have to know that the function is continuous. C is given to be differentiable. Differentiability implies continuity, so yes, C is continuous. So we can use the average rate of change formula over the desired interval. C prime of 3.5 would be approximately equal to C of 4 minus C of 3 over 4 minus 3. We get these values right from the table. C of 4 is 12.8, C of 3 is 11.2, and 4 minus 3 is 1. So we get C prime of 3.5 is approximately 1.6 ounces per minute. In part B of the question, we are asked if there is a time t between 2 and 4 such that C prime of t is exactly equal to 2, and to provide justification. So this looks like a mean value theorem problem. We're given that C is differentiable, so we can use the mean value theorem here. C of 4 minus C of 2 over 4 minus 2, 12.8 minus 8.8 over 2, does turn out to be 2, and since C is given to be differentiable, we know we can use the mean value theorem and rely on its conclusion. So by the mean value theorem, which you do not need to state, you have to verify that C is differentiable, and then you have to show the work that the mean value theorem would entail, but you do not need to cite the mean value theorem specifically. However, since this work does produce a value of 2, yes, there is a value of t somewhere between 2 and 4 such that C prime of t is equal to 2. Part C of this question, we are asked to use a midpoint sum using 3 intervals to calculate the value of 1/6 of the integral from 0 to 6 of c of t dt, provide the units, and explain the meaning and context. So using the table of data, the 3 subintervals, just get that from the table. In order to show the work here, this is an approximation, so we're going to need to show some kind of sum of products. So 1/6 the integral from 0 to 6 of c of t dt would be 1/6 of the width of the first interval times the function value at the midpoint of that interval, so 2 times c of 1 plus 2 times c of 3 plus 2 times c of 5 using the information from the table or the intervals. Substituting in values from the table, we can get an expression to calculate. Now keep in mind this is not a calculator active question, so this expression right here, the 1/6 of 2 times 5.3 plus 2 times 11.2 and so on, that would be enough to earn the answer point. However, if you do calculate it out, you do get a value of 10.1, and in this context, since C of t is the amount of coffee in the coffee cup, and we're integrating from 0 to 6, and then we're multiplying by 1/6, this would be the average amount of coffee in the coffee cup in ounces over the time period from 0 to 6 minutes. In part D of this question, we are given that the amount of coffee in the cup is modeled by the function b of t equals 16 minus 16e to the negative 0.4t. And then we are asked to find the rate that this amount is changing at t equals 5. All right, so b of t is an exponential function. We should be able to find a derivative for b of t using various differentiation rules. B prime of t would be 6.4 times e to the negative 0.4t, and then to figure out how this rate is changing at t equals 5, we're just going to find b prime of 5. All right, and then that would be in ounces per minute. Now keep in mind again, because this is not a calculator active question, as you know, once we're down to just arithmetic, we should be okay. So this expression right here would be okay. This expression right here would be okay. This expression right here would be okay, but you should have the label for either one of those. And that would be the rate at which the amount of coffee is changing at time t equals 5.